Look up at the night sky. Everything seems calm, timeless, and unchanging. But what if I told you that right now, as you stare into the cosmos, one of the most colossal transformations in our galactic history is already unfolding? The Milky Way and the Andromeda galaxy, two spiral giants drifting through space, are merging, not in some distant, unimaginable future, but now. The process has already begun, and the two galaxies are on an inevitable collision course that will reshape the universe as we know it. The problem is that our human perception is incredibly limited. We look up and see a sky full of stars, but what we witness with our eyes is only a tiny fraction of the grand reality. Less than 1% of the Milky Way's true size is visible to us. What we don't see are the immense halos of dark matter and superheated gas that extend far beyond the starry disk of our galaxy. These halos act like invisible atmospheres, stretching over 1 million light-years in all directions, dwarfing the bright, glowing structure we commonly associate with our galaxy. If the Milky Way's visible disk were the size of a dinner plate, its halo would be larger than an entire house. These halos are vast, and they are not confined to the Milky Way alone. Andromeda, the closest large galaxy to us, has a similar halo, and here's where things become extraordinary. These halos are already touching. Andromeda is located about 2.5 million light-years away, but its massive halo extends nearly 2 million light-years. At the same time, the Milky Way's own halo reaches outward, overlapping with Andromeda's. The merging of these halos is happening in real time, setting the stage for a much grander spectacle billions of years from now. Despite the enormous distance that still separates our galaxy from Andromeda, the two are closing in on each other at an astonishing speed over 250,000 miles per hour. At this rate, a spacecraft traveling at the same speed could reach the moon in less than an hour. This is no slow-motion drift. It is an inevitable, unstoppable event unfolding at cosmic scales. You may be wondering how scientists even know this is happening. After all, these halos are invisible to our eyes. The answer lies in a brilliant technique used by astronomers studying distant quasars. Quasars are incredibly bright, active galactic nuclei located billions of light-years away, far beyond our own local group of galaxies. As the light from these quasars travels through space, it sometimes passes through the halos of closer galaxies, including Andromeda. When this happens, the halo leaves behind a spectral fingerprint in the light, revealing its composition, density, and structure. Using the Hubble Space Telescope, scientists have been able to observe the light of distant quasars as it filters through Andromeda's halo, confirming its immense size and its interaction with our own galaxy's halo. This ongoing merger may sound like a dramatic event, but compared to the true giants of the universe, even the combined Milky Way-Andromeda system will remain relatively modest. Consider IC 1101, one of the largest known galaxies in the universe. It is 50 times wider than the Milky Way and contains more than 100 trillion stars. If IC 1101 were placed in our current location, it would not only encompass the Milky Way and Andromeda, but would stretch far beyond them, completely engulfing the entire local group of galaxies. Our cosmic collision, as monumental as it is to us, is merely a small-scale event in the grand scheme of the universe. For now, the merging of the Milky Way and Andromeda's halos does not create any noticeable effects for us. The gas within these halos is incredibly sparse, far thinner than the air we breathe. The interaction between them is more like two faint mists brushing against each other, rather than a violent storm. But this is only the beginning. In approximately 4.5 billion years, the visible parts of the two galaxies will finally collide. When that happens, the serene night sky we know today will transform into a breathtaking cosmic masterpiece. The beautiful spiral arms of both galaxies will stretch and twist as gravitational forces distort their structures. Stars will be thrown into massive arcs across the sky, creating formations unlike anything we have ever seen. The night sky will no longer be dotted with distant stars, but will instead be dominated by an enormous galactic presence. The two galaxies will not simply crash into each other like solid objects. Rather, they will pass through one another, each galaxy's gravity tugging and pulling at the other, triggering massive waves of star formation. It will be a slow-motion dance of destruction and rebirth, played out over millions of years. But what about the stars themselves? Will the Sun and its neighboring stars be at risk of colliding with others? Surprisingly, despite the Milky Way and Andromeda, each containing hundreds of billions of stars, actual collisions between individual stars will be extremely rare. The distances between stars are so vast that they will simply slip past one another, like ships sailing in a vast ocean. However, their orbits will be drastically altered, flung into new positions across the newly forming galaxy. At the heart of this merger lies one of the most dramatic events of all, the collision of the two galaxies' supermassive black holes. Both the Milky Way and Andromeda harbor massive black holes at their centers, each millions of times the mass of the Sun. Over time, as the galaxies merge and settle into a new shape, these two black holes will spiral toward each other, eventually merging into one. This colossal event will send gravitational waves rippling across the universe, distorting the very fabric of space-time itself. The newly formed black hole will be one of the most massive in our cosmic neighborhood, exceeding 4 billion times the mass of the Sun. For Earth, the merger is unlikely to pose any direct threat. The solar system is expected to remain intact, though its position within the galaxy may shift. It is possible that our Sun will be flung into a more distant orbit or pushed closer to the new galactic center. By the time the final stages of this merger occur, the Sun will be nearing the end of its life, eventually expanding into a red giant before shrinking into a white dwarf. Whether or not humanity will still be around to witness these events is an entirely different question. Billions of years from now, the Milky Way as we know it will cease to exist. Andromeda, too, will be gone. In their place, a new galaxy will be born, an enormous elliptical galaxy that will dominate the local universe. Some astronomers have even given it a hypothetical name, Milkomeda, a fusion of Milky Way and Andromeda. The elegant spiral structure that defines our galaxy today will be erased, replaced by a vast, rounded shape where billions of stars will reside. The fate of our home galaxy is sealed, and the process has already begun. Right now, as we move through space, we are witnessing the earliest stages of this transformation. The sky above may seem unchanging, but in reality, the Milky Way is not a static island in space. It is part of a dynamic and ever-changing universe. And as Andromeda drifts ever closer, the grand cosmic dance continues, unfolding on a timescale far beyond human comprehension. What we think of as the distant future is already happening. We are living in the middle of history in the making, and the universe, as always, is in motion.